Okay, we are ready to look at the algebra review. So, remembering that a variable is simply a letter that's going to represent some number we don't know. Um, Often math teachers like to use x. Not entirely sure why, but it's come to be known as the variable to use, but it can be any variable. Typically, we don't use a lowercase l because it looks like a 1. We don't use an o because it looks like a 0. Those are really about the only ones we don't usually use. Could we use them? Yeah, just have to be sure we write them neatly, otherwise we might cause confusion. So let's get right at these here. Number divided by 2 equals 75. And a number, okay. Let's call that, let's be a typical math teacher here and call it x. I always write my x's like this, like a handwritten x. It saves it from looking like a multiplication symbol. So x divided by 2. So I can write it as x divided by 2 equals 75. Or, that works. The more common way of writing this, though, is going to be x over 2 equals 75. All right. Yeah, move on to this. Product of 8 and a number. Oh, there's my variable, is 80. So product, we got to know what that means. That means multiply. So 8, let's use a different variable, a equals 80. Notice I don't write a multiplication symbol. I could write 8 times a, but if I put a number, which we'll define later as a coefficient, right next to a variable, it automatically means multiply. So I don't need to write, 8 times x. I could, 8 times a. I could, but I don't have to. All right. Okay, so that was a and b. 7 more than a number. Ooh, more than. That sounds a little bit like we might be adding. So 7 more than a number. So 7 plus or a number plus. 7 plus n equals 23. Okay, again, I used n as my variable. It doesn't matter. 3 times a number less 1 is 20. Ooh, tricky. We have to do something here to make sure we're doing this right. Sometimes this could get a little bit tricky, right? We could say the most obvious way to read this is 3 and let's call it q minus 1 equals 20. Translating English into math is sometimes tricky because it's this writing here, 3 times the number less 1 is 20. Looks like it could almost be something like this. Well, what if we did the number less 1 first, like order of operations wise, so in brackets, multiplied then by 3. So that would look like 3 times q minus 1 equals 20. We could do that as well. In this case, there is a difference. And if I had to mark this one is correct, this one is not. Out loud, what I can say about this one over here on the right is that if I was to say that, I have to actually say the difference of a number less 1 multiplied by 3, or the product of the difference of a number and 1, something like that, is equal to 20. But, yeah, this is where we're at. So, take the simplest reading. I will generally not give you miserable ones like this. So don't worry too much about that. Alright. Generally in math, the focus is not as much on translating English into numbers, but it can happen. The focus generally actually is on solving the equation, and that's the part that people always talk about when they talk about algebra. So to solve an equation, which means to solve it means we just want to get the variable by itself or isolate the variable. All right, so what are we going to do that? Oops, let's wait until that totally disappears apparently, and then we'll fill these blanks in. We want to do the opposite of what is there. So if there's adding, we're going to subtract. If there's multiplying, we're going to divide. If there's dividing, we're going to multiply. If there is subtracting, we are going to add. That's the first thing. We're going to do the opposite of what's there, and we have to do the same thing. I'm just going to write the same to both sides of the equation, right? Think about like a teeter-totter kind of thing. If we're going to add 5 students to one side and we want it to stay balanced, we got to add 5 students to the other side and hope the board is not weak, but that's another story. Yeah, we have to do the same thing to both sides. So let's actually do this. Now, I know you can do all of these pretty much by mental math. I get that. I want you to show your work. Okay, so if you haven't shown your work, pause this video, show your work. This part here is important. Show all steps. No mental math here. Sometimes I love it if you do mental math. Today, we're using easy ones that you can do by mental math so that you can show how to do it using proper steps. So we've got w plus 12 equals 14. So we do the opposite of what is there, minus 12. So we're adding 12 now. We're going to subtract 12 from both sides. So again, do the opposite and do the same thing to both sides. We're left with 12 minus 12 is 0, so that goes away. 14 minus 12, equal sign is still there. 14 minus 12 is 2. W equals 2. And you should be able to do that mental math-wise as sort of a check. All right, here we've got f minus 3 equals 6. Well, we've got subtraction going on, so we're going to add 3 to both sides. All right, so again, we're doing the opposite. We're doing the same to both sides. Negative 3 plus 3, that's going to be 0. So we're left on this side with just an f. On this side, we've got 6 plus 3. That's going to be equal to 9. And away we go. All right. Let's take a look here at the next one. I'm taking a quick break to let my dog outside, and I'll be back. All right. Dog is out. I am back. Away we go. 11 minus b equals 5. Well, I'm subtracting b. Now, I can do a couple different things here. Probably the easiest thing, though, is we can move the b to the other side and make it positive. Okay? That's going to save me working with negative numbers. I can do this 2 ways. So let me show you the first way by moving b to the other side. I'm going to add b to both sides. Whoops, sorry. So I'm going to add b to both sides. The equal sign stays there. I don't actually need to rewrite that in the middle here. This is the line where I'm showing my work. So negative b plus b, that's just 0. So now I've got 11 equals 5 plus b. All right. At this point now, I've got to do one more step. I'm adding. So I'm going to subtract. I have a positive b. I have positive 5. I'm going to subtract 5 from both sides. I'm running out of room. And I am left with 6. 11 minus 5 is 6. 5 minus 5 is 0. I've got just a positive b, so 6 equals b. Is it okay that the b is on the right-hand side? It is okay. All right. The other way to do this actually relies a little bit on some grade 8 math. And so this is a way you wouldn't have learned in grade 7, but it works also. 11 minus b equals 5. All right, that's what I started with. I've got a positive 11 here. Okay, well, I'm going to subtract 11 from both sides. I'm going to subtract 11 from this side. I've now got something that looks kind of ugly. I've got negative b equals negative 6. Ooh, okay. Given my writing, it looks like I have negative b equals negative b. It's actually a 6. Don't know if that's a lot better. Trust me, that's a 6. All right. Next step, I've got a negative b. I shouldn't end up with a negative variable. So you know what I can do to get rid of this? I can multiply both sides by negative 1. And now I'm left with b equals 6. And again, it looks like a b equals b with my writing. So apparently for me, using a b for a variable is also a bad idea. All right, moving on. Let's take a look at this next guy here. Oops, come on. Marvelous. 3r is equal to 18, so that means 3 times r. I'm going to divide both sides by 3 because I'm multiplying here. Do the opposite, do the same to both sides. 3 divided by 3, well, that's just 1. So 1r is the same as r. 1 times anything is just itself. 18 divided by 3 is 6. And away we go. Let's move on to the next one. P over 8. So that looks like a fraction. And we're like, well, what does that mean? P over 8? I'm confused. Well, actually, remember this means P divided by 8. So what's the opposite? Well, I'm going to multiply both sides by 8. Okay. I like to write this one beside this. This is the same as multiplying by 8. Multiply this side by 8. Now, to show my work, I don't expect you to do this all the time. To show my work, though, what I end up with here is 8 times p divided by 8. 8/8, that's like 1. So this is like 1 p, 1 times p, which is just p, is equal to 4 times 8, which is 32. So if I was to rewrite this again, I can say, okay, p equals 32. If I was normally doing this, I would, at this step here, I've got 8 times p over 8. I've got 8 on the top of my fraction, 8 on the bottom. Cross them out, I'm left with p equals whatever 4 times 8 is, which is obviously 32. Alright, those are generally one-step equations. This guy's a bit weird, but it's just because of the negatives. But essentially one-step equations. Okay, let's move on to some two-step equations. Alright, so here we've got to do the same thing to both sides. We've got to do opposite of what's there, but what order do we do it in? Well, we do the reverse of order of operations. That's one way to look at it. I prefer, generally, that's not how my brain thinks about it. If that works for you, great, use it. But what I like to do is I like to think, okay, I want to get the variable by itself. But before I can get the variable by itself, I have to get the variable and the coefficient it's with by itself. So I got to get this 6p thing by itself. All right. How do I do that? Well, I've got that 6p thing minus 8. So opposite of minus is going to be plus. I'm going to add 8 to both sides. All right. So I've got 34 plus 8 on this side. 6p minus 8 plus 8. So the minus 8 and the plus 8 cancel each other out, which is what I wanted. 34 plus 8 is 42, is equal to 6p. Now I've got 6 times p is equal to 42. Okay. Opposite of multiplying is dividing, so I'm going to divide both sides by 6. And I'm left with 42 divided by 6 is 7 equals p. Alright, let's go over to this guy here. Same idea. I want to get the thing with the variable by itself. So in this case, I want to get the 4x by itself. That's kind of my first step. I'm adding 7 to that in the question, so I'm going to do the opposite. So subtract 7. I'm going to do that to both sides. I'm now left with 4x equals 23 minus 7 is 16. 4 times x, okay. Opposite of times or multiplying is dividing. So I'm going to divide this side by 4, which means I got to do the same thing to the other side. 4 divided by 4 is 1. I've got 1x left. X is equal to whatever 16 divided by 4 is, which is, in this case, 4. And there we go. We are done.